We all have noticed how corrosion takes place. It starts from the surface. Similarly, in an electrochemical conversion, the ions move towards the surface of the electrodes. Even in dissolving substances, solvent interacts with the surface. Similarly, during formation of crystals, also we require a surface. So, the fifth chapter of chemistry is about the phenomena which require a surface to occur. That is surface chemistry. So, surface chemistry is the branch of chemistry which deals with the phenomenon that occur on surface or interfaces such as corrosion, catalysis, crystallization, etc. The topics which we will cover in this module are adsorption, how adsorption is different from absorption, mechanism of adsorption and types of adsorption. Look at these two pictures. How are these two pictures different? In the first case, particles are at the surface, but in the second, they have moved inside the surface. This accumulation of molecular species at the surface is called adsorption. But if the particles penetrate in the bulk, it is termed as absorption. The surface on which the species of a substance accumulate is termed as adsorbent, and the particles which accumulate on the surface are known as adsorbate. In a solution of an organic dye, when animal charcoal is added and the solution is well shaken, it is observed that the filtrate turns colorless. This happens because the molecules of the dye accumulate on the surface of the charcoal. Similarly, a gas like oxygen, hydrogen, ammonia, when taken in a closed vessel containing powdered charcoal is shaken, it is observed that the pressure of the gas in the vessel decreases. Again, this happens because the gas molecules concentrate at the surface of the charcoal. These are both examples of adsorption. Aqueous solution of raw sugar when passed over the beds of animal charcoal becomes colorless. Similarly, the air becomes dry in presence of silica gel. In both these examples, solid surfaces hold the gas or the liquid by virtue of adsorption. When the molecules leave the surface, that is, opposite of adsorption takes place, the process is called desorption. Now look at this example. Here sponge is put over water. Is this also an example of adsorption? No, because the particles of water move into the sponge. Therefore, it cannot be called as adsorption. And whenever the particles move in the bulk, we call it as absorption. Listen carefully. A-B, absorption. Therefore, the two terms adsorption and absorption differ as when the molecules adhere to the surface, it is adsorption. When the molecules move into the bulk of the phase, it is absorption. Here is the difference between absorption and adsorption. Absorption takes place when atoms, molecules or ions enter the bulk. Adsorption takes place when the molecules are at the surface. Absorption is a bulk phenomenon, adsorption is a surface phenomenon. Absorption is always endothermic, while adsorption is exothermic. Absorption is not affected by temperature, but adsorption depends on temperature. When charcoal is added to methylene blue, the methylene blue molecules, that is the adsorbent molecules, are not surrounded by atoms or molecules of their own kind, and they feel unbalanced attractive force towards the surface of the charcoal, due to which they are adsorbed. Adsorption can be of two types, depending upon the force between the adsorbate and the adsorbent molecules. First type of adsorption is physisorption or physical adsorption. If adsorbate adheres to the surface through weak intermolecular interactions, that is van der Waals forces, we say the adsorption is physical adsorption. When in adsorption, the molecules or atoms are held to the solid by chemical bonds, it is known as chemisorption or chemical adsorption. Are the differences between physisorption and chemisorption, and these two differ on the basis of the force operating, heat of adsorption, whether the process is reversible or irreversible, amount of activation energy required, effect of temperature, effect of surface area, and specificity. So today we learned about adsorption, mechanism of adsorption, and types of adsorption. Thank you.